Welcome to week 2 of statistics. So, a couple reminders in the announcements section. Check that out every week. If you didn't make one of the live sessions last week, get in touch with me and we can do a one for you this week. There's a few people I still would like to talk to. And then I post in here some kind of image information related to the stuff we're doing this week. I found this cute graph online. Scrolling down. I don't know if any of you are soccer fans. I am. And so I found an interesting infographic related to the World Cup and the money the clubs, big soccer clubs in the world, get for having their players go on a World Cup team. They get some reimbursement for that. They make a little cash, just quite a little. Interesting, isn't it? Course information. Textbook, you've got the web book, link to grab the PDF. You can get it from the BMCC bookstore if you haven't already. I'm pretty sure everyone read the syllabus, did the syllabus quiz, did your autobiography. We're looking at organizing data this week, which is beginning of chapter 2, sections 1 through 4. And let's get into it. So, week 2. So, typical setup of the weeks is a brief introduction of the main ideas, the things we're going to look at, and the things I expect you to be able to do. We've got a brief list of the important vocabulary that's in the textbook, and here's a link to the web book. And sometimes I like the web book to look stuff up. Other times I like the print book, and I have a downloaded the PDF here. I also have a printed copy, and I jump back and forth between the three of them. At the very least, you will have the web book and the PDF of the book that you can look at. So, for example, a little later, there's some important formulas we'll take a look at on page 92 and 93. Some videos from the authors, me, and some other statistic teacher friends out there. If you have any questions about this week's material, and then your assignments, some practice problems you get to repeat over and over again, critical thinking, where you're going to write some answers in sentences, take a look at what other people wrote, and then you can reply to your own post to make any corrections or additions. Some more videos using Google Sheets and Excel, and even one by hand here. We're playing with some of the main concepts. And then the application for this week is a data set on the percent of uninsured people in each state from 2016. And you're going to make some pretty charts and graphs related to that data for your application. So, an overview of this week. Previously, we looked at random sampling, that it's a challenging thing to do, and there's many, many, many techniques to try and get a good random sample. We could do a whole series of classes just on that, but we just did a brief introduction last week. Ideas of data sampling and variation, and then frequency tables. So, in terms of playing with data, it's hard to just look at numbers, and so we humans prefer charts. Bar charts are a very popular way of representing data. Here we have what's called a Pareto graph below, where we order the columns from largest to smallest. And that makes it a little more readable to us. We can see a pattern there, and that's pleasing to humans. Similarly, we could make a pie chart with the same data, and organizing that pie chart instead, say alphabetically, we could organize it by the size of the pie coming around here clockwise. And again, that can be more appealing, more informative to people when they're trying to get an idea of what are we looking at with ethnicity in students. A special kind of bar chart based on a frequency distribution table is called a histogram. And so that's what I have here. I'll go a little more into histograms this week, and so will you. So here I'm looking at students' exercise, how many hours per week they exercise, and over 75 of the students that were surveyed had 0 to 4 hours of exercise. Majority of students in this column here did 5 to 9 hours per week, so over 100 students. And very few students exercise, say, from 30 to 40 hours per week. So we can see we have this distribution of the amount of hours students exercise. And frequency is count. How many students were in this group between 10 and 14 hours? About 100. Now, in chapter 2, we're going to continue with some charts that were introduced in chapter 1, and we're going to just kind of expand what we have there. So, it's the idea of a stem and leaf chart. Stem and leaf chart is where you take a particular data set. Here we have numbers that are in 2 digits, and the tens digit represents the stem, and the ones digit represents the leaf. So, you can see here there's a 32 and another 32, and the stem and leaf put together give me a 32 and another 32. I can see there's a 33, a 34, and a 38. So the leaves here in the 40s represent 40, 42, 42, 43, 44, and so on up to 49. So it's kind of like a bar chart, and except instead of having a bar that stacks showing the information, I just have, say, the one of the digits, the rightmost digit here and the leftmost digit there, representing the numbers. So I can see there's more people in the 40s. Oh, sorry, what's this data for again? I forgot. Park City baseball team scores. Aha, there were more scores in the 40s than in the 30s, 50s, or 60s. Other types of graphs, line charts. Often line charts are used for time series data. So that's when we have consecutive years, consecutive months, consecutive days, weeks, and so on. And we take a look at what a particular value was there. So the green graph here is per capita consumption of sour cream, and that's measured in half pints. And so we can see in 2000, the average person consumed 6 half pints of sour cream in a given year. And then it went up to a high of 2005. The average American was consuming about 8 half pints of sour cream per year. Think back to 2005. How much sour cream were you eating? Was there something going on that made you eat more than previous or years after that? Interesting thing to think about, maybe. Comparing that to motorcycle riders killed in non-collision transport accidents. And notice how these guys kind of increase and then decrease together. That's an idea we'll look at in a couple of weeks called correlation. And line graphs drawn together can help me find correlation between data. Is there some link between consumption of sour cream and motorcycle riders killed? I doubt it, but interesting, maybe. Other types of line charts and bar charts. So I mentioned the histogram earlier. A histogram is a frequency table turned into a graph, and we saw this one on the previous page. Similarly, I can take those same numbers, what is this, maybe around 80, 110, 105, and I can plot those as points instead and then connect the dots. So this is a line graph, sometimes called a frequency polygon, and you'll read about that in 2.1. So a variety of types of line graphs. We have a time series line graph. We have a frequency polygon line graph. Stem and leaf is kind of like a bar chart, similar to a histogram. More detail on histograms in 2.2. And again, what is a histogram? A histogram is a bar chart based on frequencies. When we try to find frequencies, we generally group our data together. Those groups are called intervals or classes, groups, bins, or buckets. And those different words that mean the groups of data you're looking at, the intervals of data are important because each piece of software uses a slightly different term. And so it's good to know that when a particular program says, what is your bucket size or how many buckets you want, you know what that means. Now, there is no best frequency table. There is no best histogram, which is a graph of a frequency table. Generally, when I have some data and I want to make a display of it like this, showing the distribution of numbers, I'm going to make multiple frequency tables. I'm going to look at each of them visually and decide which graph is more appealing to me and my audience and why. And usually you want somewhere between 5 and 20 categories, which would be columns here, and that just kind of depends. And so you have to look at this and say, which one do you want to use and why? What does it point out to you? What can you use to point out to your audience? In order to make a histogram, I usually do some calculations ahead of time. Like I want to know what is the minimum value of the data, what's the maximum value of data, and then what's the range, the distance between the min and the max. How many data values are there? Because when I group them, that'll kind of go into about how many are going to be in each column potentially. And there's no best way to do that. There's just different ways to do it. And taking a look at the book and some of the videos in the week 2 material will help you figure that out. But generally, for me, I make at least 3 frequency tables, turn those into graphs, and then I pick one and go from there. Once I pick one, I'm usually going to make it a little more human readable. So here I inserted a column in between my bin max and my frequency column. And so I can clearly display to my audience that this column represents people who exercise from 0 to 4 hours, people who exercise from 5 to 9, and so on, 10 to 14. Whereas when I look at one of these other charts over here, it's harder to tell. What do you mean 2? Is that people that only exercise 2 hours, only exercise 5 hours? Is 2 the max or the min of that column? So it's kind of unclear when I'm looking at that. So I had to make this extra column and then rebuild the chart. And there's videos of me doing that in week 2. Google Sheets will automatically make histograms for you, skipping the frequency table, which is kind of nice because frequency table is a little labor intensive. And so when I first fed Google a list of 361 entries for students' hours of exercise each week, Google said, hey, I think this is a nice histogram. And then I decided to change it and said, no, I think I want to have less buckets, less classes. And so then I had Google make that for me. So I'll just show you that quick. It is available in other videos also, but it's kind of cool. So my student survey data, I have a lot of information from a survey that was done on some students here. I was just trying to isolate the exercise portion. So I'm gonna copy that into a new chart. We'll call it histogram. And anytime you're working with a spreadsheet, you wanna label any new tabs that you make and you wanna label your data so that when you look at it or somebody else looks at it later, they know what the heck they're looking at. To have Google automatically make a histogram for you, you just select the data. If the data is the only thing in that column, you can just click on the column heading to highlight the whole thing. If there's other things in that column, then you want to manually click and drag to grab your data. Here I know that's the only thing in the column, so I can select it and then choose the chart, insert chart wizard. Google automatically says, hey, you want a histogram for that? Zoom out a little and I say, yeah, histogram would be nice. Sorry, my computer's making funny noises. So it picked a histogram. If it didn't pick the histogram automatically, then you could just scroll through the possible graphs until you come to, come on, histogram and select it. Google is guessing at how to group the data down here. If you decide you don't like that, you can always customize it and change the histogram by picking, instead of automatically having Google pick the bucket size, you could pick the bucket size yourself. So maybe I want to go every 5 units. So then it'll group together 0 to 5, then 5 to 10, 10 to 15. When Google uses their auto histogram thing, the lower number is in the bin to the right. So this would really be 5 to 9 here. The next column right here would really be 10 to 14, and then 15 to 19. Whereas when you use the frequency function, it goes the other way. The last number listed is in that group. So it's kind of, it's backwards, left and right, as to which number's in the group when you use the frequency command to make a histogram versus when Google does its auto histogram. Don't ask me why, it's just the way it is. And so what you could do is you could just make a, make a few of these and then decide which one you think is best. So reselect the data, say Google, give me another histogram, and go customize the histogram to pick a different bucket size. And you can type anything you want in there. Maybe you want the bucket size to be 7, enter, and it'll redraw for 7. I don't like 7. Maybe I'll go for 8. Too wide. Maybe 6. You can just kind of play around trying to find something that works, that is revealing and attractive in some way. So I have these different histograms I can make. And once I make a few, I just kind of line them up next to each other and try and decide which one I like better and why. What does it point out to me about the data? And that is and kind of sometimes it's an aesthetic question, sometimes it's more than that. And it's just something you have to figure out and come up with your reasons. All right, moving on. Another idea you're going to look at is given a data set, the rank. So you'll see this anytime you take a standardized test and a variety of other things. So I took my exercise data and I told Google Sheets to order it for me. You can do the same thing in Excel. So 0 is the smallest, 40 is the biggest number. Rank means what position in the list is a number. So I have zeros here that are in positions 1, 2, 3, 4. Now you may say they're all the same number. Well, yes and no. This belonged to one person. This 0 belonged to another person. That 0 belonged to another. So, maybe this is Gary, Ruby, Julia, and Michelle. Um, so that there are 4 different zeros. They belong to 4 different people. That is very important. The idea of a percentile is, so for example, I asked the computer, what's the 90th percentile? 90th percentile on paper is abbreviated P for percentile, a little subscript of 90. When I'm typing on a computer, I do P underscore 90. And so the Google said the number 15 is the 90th percentile. That means there's a 15 in the list, so that 90% of the data is less than or equal to 15 hours per week. Okay. So that means there's only 10% of the people that exercised more than this person who exercised 15 hours per week. So that's percentile. It's the 90th percentile is a number in the list. Percentile rank kind of goes the other way. If you pick a number in the list, let's say I exercise 20 hours per week and I want to see how I compare to everybody else. So I asked Google to look at my list, column A, and look for the number 20 in there and find out what percent of the data is less than or equal to 20 hours per week. And Google came back and said 94% of the data, 94% of the students exercise less than 20 hours per week. All right, so try to help you understand what that means a little more. Let's take a look at my percentiles table, blow it up just a touch. So for example, I entered a formula here, percentile. So I'll just do that again so you can see what it looks like. So equals, start typing percent. I have all these different ones. I'm going to choose percentile, which will give me the value at a given percentile in the data set. So first they say, what's the data? So either highlight your data or select the whole column if that's the only thing in the column. Always be careful about that decision. Percentile needs to be given as a decimal. So if I want the 90th percentile, I have to enter 0.9, which is 90%. And then I can close it. Google looks at the list and says, hey, the number 15 is there. And so down below here, I just typed that formula that's above. Okay, so that's percentile. Percentile rank means a particular data number, like somebody exercised 20 hours per week. You want to find out where they sit in the list, in an ordered list. So similarly for that, I want to go, so this is backwards of the problem above, percentile rank, and it says grab the data, and then what number in the list are you looking for? And I'm looking for the number 20 in the list. And Google says that ranks at 94.2. So that means 94.2% of the students exercise 20 hours or less each week. Now, just to double check that, I have 361 students exercise hours in this week. So 90% of 361 would be 324.9. So that means if I list these from smallest to largest and I look at the 325th number on the list, that should be 15. Now your data doesn't have to be ordered for this formula to work. Google orders it if it's not already and then finds the right number. But here I did sort it. And so let's say I want to go down through about 325th row. Getting there. And remember, these numbers are going to be off 1 here on the side. Okay. So you can see that there's a 15 in the 325th position would actually be this one right here because there's a heading on this right here. And notice there's a whole bunch of 15s. Look at all of them that way, and there's some more that way. Okay. And there's a formula in the book that says how to deal with percentiles when you have multiple numbers, which is often the case. And that's on 392 and 393 in the print book. Percentile rank, it said the 20 hours was in like the 94% precision. And if I take 94% times 361, that gives me the 340th number in the list. So if I scroll down toward the end of my data, okay, there's 361 numbers in the list. I want the 340th, which should be one of these 20s. And it grabbed the first 20, so in the 340th position. So percentiles are a way of ranking numbers, and they're popular in standardized tests, among other places. So you get a little experience with that. Now, there are some special percentiles, like the 25th percentile, the 50th percentile, and the 75th percentile. We call those quartiles. Quartiles are involved in what's called a box plot, which is a 5-number summary. And let me blow this up just a touch. And this can be generated in a variety of programs. Oops, I guess I made that too big. Right there. Okay. So here I took my data from Google Sheets and put it in StatKey. I'll show you that in a sec. And then StatKey automatically reports back to me how many numbers are in the list, what's the average value, what's the standard deviation. We'll talk about those next week. Then it gives me the minimum. Q1 is the quartile 1, which is the 25th percentile. Let's make a note of that. So Q1 is what's called the first quartile. And a quartile is a position that marks where 20%, 25% of the data is below that point. So that's the same thing as P25, which is the 25th percentile. Median would be the 50th percentile, and Q3, the third quartile. And now remember, we got to distinguish between a quartile, a position, and a quarter, which is a whole block of numbers. And so that's what this graph does down here. So what I do is I make a mark for the minimum. So that would be, the minimum is 0. I make a mark for the maximum. I make a mark for the median. I make a mark for Q1, 5, and Q3, 12. I draw a box around Q1 and Q3 with a line down through the median. And then I draw these little feelers out, these whiskers in each direction. Now, there's different ways to draw a box plot. So you may be wondering why they stop theirs there. When the book goes over this, they say go all the way out to the maximum there. So in the next slide, I'll go over why StatKey decided to stop there. So I'll just show you this in StatKey next. 2 ways to get your data in there. You can just highlight all of your numbers and then copy and paste them in there. Alternatively, you can make what's called a CSV file, comma separated values file, and put it in that way. So what I did is I made a file called the comma separated values file, and then I uploaded it in there. So quick demo on that. I'm going to make a new spreadsheet. I'm going to call it exercise comma separated values, CSV. I'm just going to grab this column right here, copy, and paste it in there. I don't want anything else. Now, it turns out it's okay if you have other stuff in there. StatKey will double check with you. All right, and then what I want to do is I want to download that as a comma separated value sheet. And then that gets downloaded to my computer. So then I go to StatKey, and I say I want to do one quantitative variable, and I want to upload my file. It says, okay, where is it? And I say, here it is right there. So you got to find your file. And then it says, okay, please select the quantitative variable. So if you had multiple columns or multiple sheets, you'd be able to say, oh, I want that one right there. And then say, okay. Throws it in immediately and shows you a dot plot. It gives you a count of the numbers and it gives you all the common summary statistics. We've talked about min, Q1, median, Q3, and the max. We'll talk about mean and standard deviation next week. Excuse me. Similarly, you could have edited their data, deleted what they had, and pasted in your data from your spreadsheet. So that'll work too. So then I can say, hey, give me a box plot. And so maybe you like this box plot right here. Down below, if you point at a column in the lower right, it says, hey, the lower bound there is 20, the upper bound is 24. There's 13 things in that column right there. If you don't like the choice they made for the number of buckets, columns, or bins, then you can just adjust the slider to make more or less. And so sometimes the slider is a little awkward to work with, like trying to get 8 versus 10. So you can always go to set limits and type your own number of buckets in there. So I'm going to choose, since they're going 5, 10, 15, 20. If you take 5 into 40, you get 8. So if I set the number of buckets to 8, then my column divisions will line up with their axis. No big deal. I can kind of tweak that a little bit, but not too much here. So here's one version of the histogram. They'll also show me the box plot, and you'll see that's the same box plot I copied and pasted into my slideshow over here. And what I like to do is I like to show a histogram and a box plot above or below each other with the exact same scale. I'll talk more about that later. That gives me more information about the distribution of data. Okay, next. Making a 5-number summary by hand and using that to figure out the idea of outliers. So here I made those same calculations, but I did it in Google Sheets. Doesn't matter whether you do it in Google Sheets or you do it in StatKey or Excel, as long as you can get the min, the quartile 1, the median, quartile 3, and the max. Once you have those, the next step in drawing your box plot would be to, and you can pretty easily draw it by just plotting those 5 numbers, minimum, Q1, median, Q3, and the maximum. So that's a quick box plot, the basic way. But we're going to enhance this one by looking at the IQR. IQR stands for interquartile range. Range is just a distance. So that means within the quartiles, what's the spread here? Okay, well, no problem. You just take Q1 and subtract, or Q3, sorry, and subtract Q1. So 12 minus 5 is 7. So my interquartile range is 7. So that's the distance from here to there. Then what I do is I multiply that by 1.5. Why 1.5? That's a long story I'm not going to get into. So, and what I want to do is I want to take that extension of the interquartile range and say, okay, where does that put me out to the right of Q3? Where does that put me out to the left of Q1? So I just want to extend the interquartile range. So that's what I'm doing next to deal with outliers. So next we extend the interquartile range. So again, to do that, I take Q1 and I'm going to move to the left, subtract 1.5 times the IQR. So 1.5 times 7 is 10.5. 5 minus 10.5 is negative 5.5. That puts me over here, right? So that's kind of a weird number because you can't exercise a negative number of hours per week. So basically that means nobody exercised too little, right? Because 0 is the least you can do. And there were some people that didn't exercise at all. The upper end of where we're going to look for outliers is take Q3, extend that 7 1.5 times. So that means from my 12 here, I'm going to jump out 10.5. So 12 plus 1.5 times the IQR, that gives me 22.5. Now this number is important because it is within my data set. And so any number that's bigger than 22.5 out here on the side is unusually large number of hours compared to everybody else. So these numbers out here are unusually high compared to everybody else. So every data set has a different range, which we could say normal is normal based on the other people in that data set. And StatKey basically calculates that number right away for you. They don't show it though; they just graphically display it, but they don't tell you what it is. So if you look over here, there's 20, there's 25. I think they're probably rounding it down to about 22 there. And then they're saying, hey, there were these numbers outside of that are in your data set, but we would consider those outliers. So notice I have outliers, numbers that were unusually high compared to the other people, but nobody was unusually low since we had a zero, multiple zeros in there. And five number summary makes box plot. You can extend the box plot to talk about outliers. So those are numbers that are unusually high compared to everyone else or unusually low compared to everyone else. All right, there's my summary for this week. You have the rest of the week to try and grapple with these ideas and start applying them. Good luck and get in touch with me if you have any questions. Take care and do good math.